Hey, 21B students, this is the solutions to the practice midterm that I wrote for you all. Let's get going. So, 21B practice midterm solutions. This is not to be confused with the practice midterm that Babson wrote. It is very similar to the one he wrote, but it is different. But this is the one that I wrote and will have posted by the time this video is available. So, question 1A is to find the following summation, the sum from k equals 3 to 7 of 4k minus 3. So in an instance like this, I think that this is few enough terms that you should just write it out. So what I really have is, you could actually do one small thing. You could break it up as 4 times the sum from k equals 3 to 7 of k minus the sum from k equals 3 to 7 of 3. Okay, how many terms are we adding up here? Well, this is going to be 4 times 3 plus 4 plus 5 plus 6 plus 7. The reason I wrote that is because it tells me I have 1, 2, 3, 4, 5 terms. 7 minus 3 is 4, but you have to add 1 back to count the number of terms you have. So what you're doing here is you're adding up 3 5 times. So it's going to be minus 3 plus 3 plus 3 plus 3 plus 3, or 5 times 3. So that's going to be, let's see, 3 plus 7 is 10, 4 plus 6 is 10, plus 5 is 25, so that's 4 times 25 minus 15, which is 100 minus 15, which is 85. The second problem, the sum from k equals 1 to 50 of 2k is not meant to be done by writing it out. Here, you could pull out the 2 and write it as the sum from k equals 1 to 50 of k, and then we know the formula for the sum of the first n integers is going to be n times n plus 1 divided by 2, right, where our n here is 50. The 2's cancel, and you get 50 times 51, which is what? 5,100 divided by 2, so that's going to be 2550. Moving along. Question 2 says a toy plane flying in the air is observed for 20 seconds. The velocity of the plane is recorded every 5 seconds and listed on this table. Here's the table, by the way. So we'll try to make this so we can do this. There's our table. So the question says to first estimate the distance the plane traveled during these 20 seconds in the following ways. So here's the, we'll write all these things. So first, L4, using 4 equal intervals and the left end point rule. So, or the left end rule, whatever. So what we're going to do is we're going to say, okay, well, each of our time intervals is 5 seconds long. So our distance is going to be approximately equal to L4. L4 is going to be, well, our first left endpoint is going to be essentially our function evaluated at 0. So the velocity at time 0 times our delta t, which is 5 seconds, plus our velocity at time 5 times our delta t, which is 5 seconds, plus our velocity at time 10 times 5 seconds, plus our velocity at time 15 times 5 seconds, right? It's always just going to be a velocity times a time to get a distance. So that's going to be, and let's factor out the 5, and so that's going to be v of 0, which is 12, plus v of 5, which is 8, plus v of 10, which is 10, plus v of 15, which is 6. We should only be adding 4 things together since it's L4 using 4 equal intervals. Let's say that's going to be 5 times 20 plus 10 is 36, 5 times 36. A fast way to multiply by 5 is to multiply by 10 then divide by 2. 36 times 10 is 360, divided by 2 is 180. So we'd say that's 180 meters is the distance we're approximating that we traveled, okay? Instead of using R4, I decided to ask for U4, the upper sum. So now here we're going to say D is the approximately the upper sum over 4 intervals. The time intervals are still the same, but now for each interval, we have to pick the larger value. So for the first interval from 0 to 5, we're going to pick 0 because that's going to give you the bigger output. So it's going to be 5 times 0. For the second interval from 5 to 10, we're going to pick 10 as the input because that has the larger output. You're basically just picking whichever value gives you the biggest thing. From 10 to 15, we're also going to pick 10 because that gives you the larger output. And from 15 to 20, we're going to pick the input of 20 because that gives you the larger output of 14. So adding this up, that's going to be 5 times 12 plus 10 plus 10 plus 14, which is going to be 20, 46 times 5, 6. 460 divided by 2 is 230 meters. From the last question, the average of L4, R4, and M2. So let's do this relatively quickly. So sure. So we already have L4, right? L4 is 180 meters. R4 is almost the same as L4, except instead of using the left, you use the right. So you're just going to essentially leave this first term off and add on that last term there. So R4 should be 5 times 8 plus 10 plus 6 plus 14 instead of 12 plus 8 plus 10 plus 6. So that's going to be, let's see, 14 is 2 more than 12. 5 times 2 is 10. So this should be 190. Let's double check. 18 plus 20, yep, that's 38. And 5 times 38 is 190 meters. And finally, M2. So we're pretending like we have two subintervals. So essentially we're saying this subinterval and from 0 to 10, yeah, sure, from 0 to 10, and then another one from 10 to 20. So from 0 to 10, the midpoint is 5, and V of 5 is 8. So it's going to be V of 5 times our delta t. And then on the second interval from 10 to 20, it's going to be the midpoint, which is 6. Kind of low values there, plus V of 15 times delta t. So that's going to be V of 5, which was 8, times delta t, which is 10 seconds, not 5 seconds, plus V of 15, which is 6, times another 10 seconds of interval. So that's going to be 14 times 10 is 140 meters. And finally, this asks us to average the three of those. So we're going to get 1/3 times L4 plus R4 plus M2, right? Or all of them added together divided by 3. Sorry, I can't quite see that. Apologies. That's going to give us, let's see, 180 plus 190 plus 140 divided by 3. Let's see, 18 plus 19 is 37, plus 14 is 47, 51. That's 510 divided by 3. It is divisible by 3 because 5 and 1 add up to 6. That's going to be 170 meters. Cool. All right. Let's look at question 4. Sorry, question 3. That was question. Yeah. So I've been labeling these things terribly. That was question 2, parts A, B, and C. Sorry. This was 2A. That was 2B. This was 2C. Sorry for my terrible labeling there. There you go. So now on to question 3. So 3A says the following. It says write a definite integral for the function SLG of x. So SLG of x is equal to the area under the curve y equal to 4 over the cube root of e times sine of natural log of t. Area under that curve between t equals 1 and t equals x. So that means we want to have the integral starting at 1, ending at x of that function. So the integral from 1 to x of 4 over the cube root of e times sine of natural log of t dt. All right, that's it. That's the whole answer to 3A. 3B says the following. I want to find the derivative of that function evaluated at x cubed, and then plugging in x equal to 10. So when I do a problem like this, I like to find the derivative part first and then just using x's and then plug in 10 afterwards. So I'm going to say that just the derivative of my SLG of x cubed is going to be the derivative of the integral from 1 to x cubed of 4 over the cube root of e times sine of natural log of t dt. The derivative of the integral, we're just going to plug in the x cubed where we see the t, so that's going to be 4 over the cube root of e times sine of the natural log of x cubed. But then we have to multiply by the derivative of the thing we plugged in. And the derivative of x cubed is 3x squared. That's it. You could simplify this a tiny bit if you really wanted to. You could write this as 12x squared times sine of natural log of x cubed, all divided by the cube root of e, if you wanted to. And then plugging in 10. So the derivative with 10 plugged in, just plug in 10. So you can get 12 times 10 squared times sine of the natural log of 10 cubed divided by the cube root of e. And I wouldn't do any more work. Obviously, you could do more work here, right? 10 squared is 100, 12 times 100 is 1200. Sine of natural log of 10 cubed, you could write that as sine of natural log of 1000, or you could bring the 3 down in front and write it as sine of 3 natural log of 10. But I don't think we really need to do any of that. I would just leave it like this. We've done the important part. All right, next question 4, which has multiple parts. So question 4 is asking us to find some indefinite intervals. So here's 4a. 4a says we want to find the indefinite integral of x cubed plus the 4th root of x minus 1 over x. Yeah, so let me rewrite that. That's kind of not great. Let's try that again. Sorry. It was the integral of x cubed plus the 4th root of x minus 1 over x dx. And I would say it really does make sense to rewrite this as x cubed plus x to the 1/4 minus 1 over x dx. And then for these powers of x, you're just going to add 1 divided by the new power. So that's going to be x to the 3 plus 1 divided by 3 plus 1 plus x to the 1/4 plus 1 divided by 1/4 plus 1 minus, now for 1 over x specifically, that's the function whose antiderivative is the natural log of, well, it's actually the natural log of the absolute value of x. That's why I like to leave it as 1 over x. I don't like to write it as x to the negative first because I can't use the anti-power rule there. We should simplify this, although if you didn't have time, it would be not incorrectly like this. So that's going to be x to the 4th divided by 4. 1/4 plus 1 is 1/4 plus 4/4, which is 5/4. And instead of saying divided by 5/4, I like to say multiplied by 4/5. And then minus natural log of the absolute value of x. Plus, we definitely do need the constant there. Cool. That's not so bad. Let's look at the next one. 4b. We want to find the integral of sine to the 4th power of 6x times cosine of 6x. So for a problem like this, where you have a power of sine and cosine, as long as one of the powers is odd, you're safe to do a u substitution. If they're both even powers, it's a whole different story, which is kind of terrible. But if one of the powers is odd, we're safe. So here, we want to let u equal sine of 6x. Or derivative du dx would equal cosine of 6x times 6. So du would equal cosine of 6x times 6 times dx. And look, I essentially have that. I have a cosine of 6x times dx. So I'm going to take my du and multiply both sides by 1/6. So that 1/6 times du is equal to cosine of 6x times dx. So this cosine of 6x times dx is exactly equal to 1/6 times du. And then my sine to the 4th of 6x is exactly going to be equal to u to the 4th power. So we can rewrite this as the integral of u to the 4th times 1/6 du. Or most people would probably just bring that 1/6 out in front automatically and say it's 1/6 times the integral of u to the 4th du. We integrate, we get 1/6 times u to the 5th divided by 5 plus c, which would then end up equaling, let's see, 6 times 5 is 30, so that's going to be my u to the 5th power divided by 30 plus c. And my u was sine of 6x. It's totally fine to write it like this, but a more normal way of writing this final answer is sine to the 5th power of 6x divided by 30 plus c. Not too bad. Keyboard's in the way here. It's down just a little bit. Okay, cool. So hopefully you can all see that. Let's look at 4c. 4c is a little tricky, I think. 4c says the following. We want to find the integral of secant to the 5th power of x times tangent of x dx. So you have a couple potential choices for u substitution here. You could either choose u equal to tangent, but that's actually not going to work out so well. So if u is tangent, your derivative is secant squared. There's a secant cubed left over, which an odd power of secant is not what we want left over. An odd power of any trig function is really not what you want left over if you're trying to do a u sub. There's more to say about that at another time. But if we let u equal secant of x, we'll check this out. Our du is going to be secant of x times tangent of x dx. And we exactly have that if we just rewrite this. We can rewrite this as the integral of, well, secant to the 5th is secant to the 4th times another secant times tangent dx. And oh, look, we're in good shape here because that's exactly equal to our du. And it's not great. And then secant to the 4th is exactly our u to the 4th. So we end up getting the integral of u to the 4th times du, which is going to be u to the 5th divided by 5 plus c, and then replace u with secant, and we're going to get a final answer of secant of x to the 5th power divided by 5 plus c, or probably more normally written as secant to the 5th of x divided by 5 plus c. And you can check if you took the derivative, not that you have to do this, but I'll just point out the derivative of secant of x to the 5th over 5, or 1/5 secant of x to the 5th power is exactly 1/5 times the derivative of something to the 5th is 5 times your something to the 4th. And then you have to multiply by the derivative of the inside, which is secant of x times tangent of x. And oh, look, this derivative is exactly secant to the 4th times secant, or secant to the 5th multiplied by tangent, which is exactly the thing we were integrating in the first place. So yes, this is certainly our antiderivative because its derivative is equal to the thing we were trying to anti-differentiate. Again, you do not have to check this on an exam. I'm just showing you that if we did, it should work out just fine. That's the end of problem 4. Let's look at problem 5. Problem 5, yeah. So there's a few things in problem 5 that he threw in there that I need to address. Well, actually, it's one thing really. So let's look at 5a, which is the integral. I feel like I'm going to run out of room here, but we'll see. The integral from 0 to 2 of x to the 5th times the square root of 9 minus x cubed dx. So I'll point out, this is an example of what's called a u substitution with a back substitution. If we make the quote unquote obvious choice for u, which is letting u equal 9 minus x cubed, your derivative isn't exactly there, right? We'd love to have something like, if we could, we'd love to pick something like 9 minus x to the 6th, because the derivative of x to the 6th is 6x to the 5th, and we have an x to the 5th. But that's not what's happening here. We're still going to make kind of the obvious choice that u is the stuff inside the square root. And then we'll point out that our du is equal to negative 3x squared times dx. Well, notably, this x to the 5th I can break apart as an x squared times an x cubed. So if I multiply this here by negative 1/3, I can say that negative 1/3 du is equal to x squared times dx. So I can rewrite my integral as the integral from 0 to 2. I'm going to leave the x squared out here times the square root of 9 minus x cubed, and then the other power of x, x cubed, right there. So now look what we've got. I did that backwards, apologies. I wanted an x squared times dx because that's what that's equal to, and I want the x cubed staying out in front. Sorry about that. So here's what we're going to do. The x squared times dx is going to equal negative 1/3 times du. The 9 minus x cubed is equal to u, and this leftover x cubed, we can take our original choice for u, we can isolate x cubed. So we're going to say, oh, u plus x cubed equals 9, x cubed equals 9 minus u. So if we replace the x cubed with 9 minus u, that's the back substitution part, where we're taking the leftover x things and still writing them in terms of u. We are also going to change the limits of integration. So my lower limit was x equals 0, but u is equal to 9 minus x cubed. So u is going to equal 9 minus 0 cubed, which is just 9. And for x equal to 2, u is going to equal 9 minus 2 cubed, which is 9 minus 8, which is 1. So our new limits of integration are the following. It's a lower limit of 9, an upper limit of 1. It's okay that they're out of order. That happens sometimes. Then we're going to get 9 minus u times the square root of u times negative 1/3 du. Okay, I'm going to do a couple things. I'm almost out of room here. I'm going to put this minus sign, the minus 1/3 in front, but I'm actually going to change the sign so I can change the order to be what feels like the correct order to me. So we're going to rewrite this as positive 1/3 times the integral from 1 to 9. And then the 9 minus u times square root of u, well, that's a u to the 1/2. I'm going to have 9 times u to the 1/2 minus u to the first times u to the 1/2 is u to the 1 plus 1/2, which is 3/2. Now we're going to anti-differentiate. We've got 1/3 times, that's a 3, believe it or not. 9 times the antiderivative of u to the 1/2 is u to the 3/2, so u to the 3/2 times 2/3 minus u to the 5/2 times 2/5. Sorry, I know that's really super scrunched in there. Let me zoom in a bit. Evaluated from 1 to 9. Sorry, this is very, I feel like I'm really squishing this in here to try and make it fit. I have all the paper over here, but. Okay, so now plugging in, we get, I will point out that 9 times 2/3 is 18 divided by 3, which is 6. I really need to do that? I don't know. So I have 1/3 times 6 times 9 to the 3/2 power minus 2/5 times 9 to the 5/2 power minus 1/3 times. Okay, when I plug in 1 here, I get 6 times 1 to any power is 1 minus 2/5 times 1 to any power is 1. And I don't think it is worth your time to simplify this. Or you can't simplify it, but you should do other work on your exam first. I will point out that 9 to the 3/2 is 27, and 9 to the 5/2 is kind of gross. It's 243. So if you want to simplify this, you have 1/3 times 6 times 27. 6 times 27. I should multiply the 1/3 first. I should leave this as 6 times 27 minus 2/5 times 9 to the 5/2 is 243. That's gross. Minus, I could distribute the 1/3 here. 1/3 times 6 is 2. And 1/3 times 2/5 is 2/15. But we're not really getting anywhere great here. So yeah, you could do this, but I really don't think it is worth your while. I'm going to finish it because I can't help myself. So here's what we've got. So this simplifies even further. That's going to be, so I'm going to write this again. 1/3 times 6 times 27 minus 2/5 times 243. And then minus, I'll distribute 2 minus 2/15. Sure. Yeah. So then we're going to have 1/3 times 6 is 2 times 27. 1/3 times 2/5 is also 2/15 times 243. Minus 2 plus 2/15 seems terrible. 2 times 27. That's a 7, believe it or not. Yeah, 2 times 20. How did I write a 5? 2 times 27. Sorry. You should skip this part. This is 2 times 27, 54, minus 2 is 52. And then you have a minus 2/15 times 243 minus 1. This is just silly. So you have something gross, 52 minus 484, 15. And I would stop there. You can get a common denominator and go further, I guess, but yeah. So that problem is gross. Let's look at the next one. We'll talk a little bit more about that back substitutions in class on Tuesday. Let me zoom back out here to a more appropriate level here. So let's look at 5D. The integral from 0 to 1 of 2 minus x squared times 6x minus x cubed. Something you might have noticed in the last problem is I did a u sub and I didn't turn back into x's because I didn't need to. When you do a u sub for a definite integral, I highly recommend changing elements of integration. So we're going to do a u substitution here as well. We're going to let u equal 6x minus x cubed. Du is going to be 6 minus 3x squared dx. And if you factor out a 3, your du is equal to 3 times 2 minus x squared dx. And oh, look, we have a 2 minus x squared. So we're actually really thrilled to say that 1/3 du is equal to 2 minus x squared dx. So if we rewrite this, I'm going to change the orders to make it look nicer. All right, it's 6x minus x cubed. I feel like it's sorry, it was 6x minus x cubed to the 4th power. I knew I was missing something. If I didn't have a 4th power there, I would have just multiplied it out. 6x minus x cubed to the fourth times 2 minus x squared dx. Again, that's going to equal my 1/3 du. This is going to be my u to the fourth. So we're going to rewrite this as the integral of u to the fourth times 1/3 du. My new limits of integration, well, my lower limit was x equal to 0. That's going to become u equal to 0 minus 0, which is still 0. And my upper limit was x equal to 1. That's going to become u equal to 6 times 1 minus 1 cubed, which is 5. New limits. So now we're going to integrate. We're going to get u to the fifth over 5 times 1/3, evaluated from 0 to 5. So that's going to be 5 to the fifth divided by 5 times 3 minus 0 to the fifth divided by 5 times 3. One of those fives can cancel there, and we get 5 to the fourth divided by 3 minus 0. And you can leave it like this, or 5 to the fourth is 625. Either way is fine. Again, for definite integrals, I wouldn't worry about simplifying them too much. Once you get to a numerical answer, you should stop simplifying and do other work. And then if you have time at the end, come back to that and simplify it further. Okay, let's do this next one. You'll probably see one like this on your exam. The integral from -3 to 0 of the square root of 9 minus x squared. So at this juncture, we are not able to anti-differentiate a function that's the square root of a number minus x squared. We will learn how to later. It's a process called trig substitution. But for now, the point of this question is that you're supposed to recognize that it's part of a circle. If you look at y equal to the square root of 9 minus x squared, you could square both sides and then add x squared to the other side and say, oh, that's a circle of radius 3. So this is the top half of a circle of radius 3, centered at the origin. So it looks like this. But we're only going from -3 to 0. So we're starting here and we're stopping here. I should say x equals -3 to x equals 0. So we're just looking at this area here. So this integral is going to be equal to how much area there is in a quarter of a circle of radius 3, which is going to be 1/4 times the area of a circle of radius 3, which is pi times 3 squared, or 9 pi divided by 4. Final answer. 5D is going to go a similar way. 5D is asking us to find the integral from -2 to 6 of the absolute value of x minus 3. So what you do when you're integrating an absolute value function, especially if it's an absolute value of a linear function, is just graph it. So the absolute value of x minus 3 is just the usual absolute value graph, shifted 3 to the right. And then I know that if I plug in 4, 5, 6, if I plug in 6, 6 minus 3 is 3, and the absolute value of 3 is 3. So right here, this point here is going to be the point 6 comma 3. And over here at -2, if I plug in -2, -2 minus 3 is -5, -5, absolute value of -5 is +5. So this is the point -2 comma 5. These might look the same height because of how poorly I drew it. Doesn't matter. This triangle over here has a base of 3, a height of 3. This triangle over here has a base of 5 and a height of 5. So my integral from -2 to 6 of the absolute value of x minus 3 is just equal to the area of this first triangle plus the area of the second triangle. So that's going to be equal to A1 plus A2. And the area of the first triangle is going to be 1/2 the base times the height. And the area of the second triangle is going to be 1/2 the base times the height. And that's going to be 25 over 2 plus 9 over 2, which is going to be 34 over 2, which is 17. Cool. So absolute value areas are really, really easy to find. They're just triangles, areas of triangles added together. Okay, let's look at this 5e. This 5e says the following. It says, find the integral from 0 to 3 of f of x if the following things are true. One, the average of f of x on the interval from 0 to 5 is equal to 4. So I would point out what that means for us is that 1 divided by 5 minus 0 times the interval from 0 to 5 of f of x dx is equal to 4. Or in other words, the interval from 0 to 5 of f of x dx is equal to 4 times 5, which is 20. And the other thing we're given is that the integral from 3 to 5 of 2 times f of x plus x dx is equal to 40. Okay, well, we can use this to figure out what the integral from 3 to 5 of f of x is. So I'll point out that the left-hand side of this equation is, I can rewrite this as 2 times the integral from 3 to 5 of f of x plus the integral from 3 to 5 of x dx is equal to 40. So then this is going to be 2 times the integral from 3 to 5 of f of x dx plus this integral is going to be, well, if you anti-differentiate x, you get x squared over 2 from 3 to 5. Plugging in, we have 2 times this integral. That part's going to be, let's see, 25 over 2 minus 9 over 2. So 25 minus 9 over 2. 25 minus 9 is what? 16. 16 divided by 2 is 8. So we're going to subtract 8 from both sides and say that 2 times the integral from 3 to 5 of f of x dx is equal to 40 minus 8, which is 32. And then dividing both sides by 2, the integral from 3 to 5 of f of x dx is equal to 16. So now here's what we can say. The integral from 0 to 5, sorry, from 0 to 3 of f of x dx plus the integral from 3 to 5 of f of x dx has to be equal to the integral from 0 to 5 of f of x dx. But we just showed that, well, we're told that this part is equal to 20 and this part is equal to 16, which means that this part has to be equal to 4. So the integral from 0 to 3 of f of x dx is equal to 4. I don't love that answer, but oh well, that's what we got. Okay, last one here is an extra credit question. This is, so I will point out, this last extra credit question is probably the only question on my test that is dissimilar from this test. He did not ask one of these. It doesn't mean he couldn't, but I can't really say one way or the other, if you will. But I'm still going to do it, and then you can prepare accordingly. So the extra credit question says, find the area under the function f of x equal to 6x squared minus 2x plus 3 over the interval from 0 to 5. So we're trying to find this interval. From 0 to 5 of 6x squared minus 2x plus 3 using the limit definition for the area of the function. So using the limit definition, it's going to equal the limit as n goes to infinity of the sum from k equals 1 to n of our function evaluated at right endpoints times our delta x. So our delta x is going to be b minus a over n, which is just 5 over n in this case. And our c sub k is going to be a plus k times delta x, which in this case is 0 plus k times 5 over n, or just 5k over n. So then we're going to get the limit as n goes to infinity of the sum from k equals 1 to n of 6 times 5k over n squared minus 2 times 5k over n plus 3 all times our delta x, which is 5 over n. So now we're just going to simplify this. So limit n goes to infinity, sum k equals 1 to n. Simplifying, 5 squared is 25, 6 times 25 is 150, k squared over n squared. Minus, let's see, 2 times 5 is 10, so 10k over n plus 3, all times 5 over n. So that's going to end up equaling the sum, sorry, the limit as n goes to infinity of the sum from k equals 1 to n. 5 times 150 is 750, k squared over n cubed. 5 times 10 is 50, k over n squared plus 15 over n. Break it apart, pull out the constants. So you're going to get 750 over n cubed times the sum of k squared minus 50 over n squared times the sum from k equals 1 to n k plus 15 over n times the sum from k equals 1 to n of 1. And then we use our formulas. So the limit then goes to infinity, 750 over n cubed times n plus 1 times 2n plus 1 over 6 minus 50 over n squared times n plus 1 over 2 plus 15 over n times n. And then I think you can jump straight to the answer and say, okay, cool. This first part's going to be 750 times 2 over 6, because the leading term on the top is 750 times 2n cubed, and the leading term on the bottom is 6n cubed, minus 50 over 2, because the leading term on the top is 50n squared, leading term on the bottom is 2n squared. Finally, 15n over n is just 15. So end up getting this 750 divided by 3 is 250, so we have 250 minus 25 plus 15, which is going to be 240. All right, so there's a second practice test for you all to practice with. I hope it goes well.